Welcome everyone to Advent of Code with Pandas. This is day 12. All right, I'm going to start assuming you've already read and understood the problem so we can skip sort of some of the intro and get right to the actual work. All right, so here is our grid of letters. This is our input. We're going from capital S to capital E, and I'm going to read this in with a fixed width format. So here is the grid of letters like this. And then I'm gonna do a little trick and I'm gonna stack every row one on top of the other into a single series of data like this. So this is pretty cool. This is like row 0, column 1, row 0, row 0, column 0, row 0, column 1, row 0, column 2. So it's just this entire row stacked. And then what's happening, the rest of the rows are stacked under that. So the result is one series of data. And this makes it finding, the first thing we want to do is find out where the location of S is. And IDX max just returns the index, so it'll be of the maximum. So it'll be a tuple over here, wherever it's true. So testing where it's true. Same for the end. So let's go ahead and see this. So that is the start location, and this is the end. So row 20, comma 0. So you can see here and line it up. And this is row 20, column 148. All right, so now that we have the location of the start and end, I'm going to go ahead and replace S with A and E with Z because that's their actual height. We don't need S and E anymore. And then I'm going to convert it to a number because it's just easier to deal with numbers instead of the letters for the height. And I will subtract the Unicode value of A and then add 1. So they're all between 1 and 26. So basically just mapped A through Z to 1 through 26. All right, and this is how you can get the underlying value. So say row 24, 140, you can just pass it in like this and you'll get its numeric representation like that. So that's how you can look up things on the grid. All right, so we have to traverse here in the shortest path possible. So from here on out, I'm not really using pandas anymore. So it's just a somewhat sophisticated, series of loops here to kind of, snake my way through the points. So the idea that I've worked out here is that whatever point I am, I'm going to just brute force. I'm going to look at all directions surrounding the point. And I'm only going to, I'm going to see which ones are valid directions I can go. So to be a valid direction, it has to be only one letter higher or lower, at most one letter higher. And it cannot be a position that I've already gone or a position that any other path has taken. So let's just say I'm at the very beginning. I can go either up, right, or down. So those are all valid directions. And then what I'm going to do is I'm going to create a new path for every possible direction that I can go. So I'll have a separate path going up, a separate path going right, and a separate path going down. And then I'll just repeat that process recursively until I get to the end result. Okay. All right. So what I'm going to do is, this is my starting path is, I'm creating a variable called path, which is just a list of lists. So the inner list is like one path. It's a list of tuples. So it's a list of tuples. That is the path. This is going to be where the final path will be until it is completed. I'm going to just set this equal to none. And then I'm going to have all points be a set. So I'm going to keep track of all the points that all of the paths have gone on. So if I've gone to a path gone to a point that I've already been to before, I'm just going to stop that path. I'm not going to continue with it because if I've already gone to it, then it's like then it's going to take the same path anyway. So I don't have to keep traversing that same path if I've already seen it. Okay. So while I have not found the completed path, I'm going to loop through all of my paths. So if I have 10 current paths right now, I'm going to go through each one at a time. I'm going to get the very last point of the path. I'm going to get the, I call it Y then X because data frames the first value for data frame is, the row direction and then the X. So it's a little bit different than your normal coordinate plane. I'm going to look up its value over here in my series S like I did right here. So that's all I'm doing here. I'm looking up the value, like its numeric value, like that. And then I'm going to check the 4 surrounding points. Okay, so I'm going to look up, down, left, and right. I'm going to get the value of each of those 4 points. This is a for loop. So I'm going to get that next value. If it can't find the value, that means if it's off of the grid, that means there will be a key error, and I want to catch that exception. And then I'm just going to continue. I'm just going to go on to the next point. There's no reason in looking for it because it's not a valid point. So say like a -1 for the one of the directions. That is invalid. All right. The other thing is that I must be 1 ahead or lower. So my current value must be 1 ahead or lower than the next value. And I cannot have seen that point before. So the next position is not in all points. So all points is that set that's keeping track of all of them. Okay, so if it's a valid point, that means it makes it past here. I'm only 1 ahead, at most 1 ahead, and I haven't seen the point before. Then I'm going to create a new path. Right, so I'm going to copy the current path, and I'm going to append this next position. So whatever this position is that it's calculated. And then I'm going to add this new point to that set of all points. So I don't ever, if I go to that point again in another path, I will just skip it. Okay, so that's basically it. If the next position is the end position, which I calculated up here, right? Here's the end. So if I reach 20, 140, then it will stop, right? I'm just going to set completed path equal to new path, and that will exit the loop. If not, I have a variable here that keeps track of all of the new paths possible. All paths.append new path. So that's the copy I made. So I'm just making a copy, appending a point, and then I'm going to just loop through that all over again, like this. So I just set path equal to all paths, and then I'm on my way to looping through again. All right, so that's all you do. The only thing that is left is to find the length of that completed path and then subtract 1, just because it's the number of steps and not the total number of spaces that you go to. All right, so that's part 1, which is kind of cool. You can actually see, I wrote a little function here to visualize it. So you can see the path over here like this. So this just highlights the background. Very cool. Part 2 is, where is the shortest path from the lowest point to the highest point? So there's a number of A's right over here. I'm going to find an A that leads us, it's going to have the shortest path to the end. So what I've done here is actually gone backwards. And you can see here, I already have it set, so I'm going to comment it out. I'm going to start at the end and then find the nearest, once I reach A, and this time the logic is just backwards. I have to, make sure I'm going down and not up. And once I reach A, so the value is 1, then my path is complete. So it's almost the same number actually, but that's how you do it. So I just have the logic over here commented out like that. All right, so that wraps it up for Advent of Code with Pandas, day 12.